Confidence intervals. Okay, so the last thing in statistics. So we have looked at the normal distribution. We shouldn't have waited, it'd be quieter. We've looked at the normal distribution. We've looked at standard deviation. We've looked at all the statistics, mean, median, mode, leading to standard deviation, leading to the normal distribution, leading to the standard normal distribution with the mean of 0 and Z scores, right, which is the number of standard deviations from the mean. Now what we're going to look at is confidence intervals. So that deals with surveys usually. So often surveys are administered to determine the opinion of a population regarding a particular issue. Yes.
Do we have this in the booklet?
Yes. These surveys can take the form of a questionnaire, a telephone survey, a poll, etc. More often than not, the survey will not be administered to the entire population. If you do administer to the entire population, then it's called a census. Okay? So the census, which they do every 5 years or that's where you are going to the entire population. You're asking absolutely everybody. We can't do that often. It's expensive and it's time consuming and it takes a long time because it consumes time. So we don't do that, right? We do surveys. So we take a small group of the population, since population is too large survey. If the group is chosen randomly, then the results should represent the entire population, but there will be some error. Okay? If you do a census, there's no error. You know exactly what everybody thinks. The larger the sample survey, the more accurately the results of the survey will represent the opinions of the entire population. So if there's an election or anything, you're always hearing about surveys for elections, right? So here we go. A survey was conducted at Town School regarding the timetable. Out of 300 students surveyed, 82% wanted a change in the timetable. The results were accurate within 2 percentage points, 19 times out of 20. Okay? Now that's what you're going to hear. If you read any survey, if we went and looked up a newspaper article on a survey, it would say the results are accurate within, and then they give you a percentage, and they would always say 19 times out of 20. So what does all this mean? Margin of error. The margin of error for this survey, say the results were accurate within 2 percentage points, means that 82% is within 2 percentage points. So how low could we go? So 80%, and how high could we go? 84, right? So we have 82 minus 2 and 82 plus 2, right? So we've got this margin of error. We say we know the results are accurate within 2%, which means we subtract 2%, we add 2%. So between 80 and 84% of all the students in the school want a timetable change. The confidence level is 19 out of 20. What is 19 out of 20? 95%. 95%. So, what does it mean? If the survey was conducted 20 times, then 19, oh sorry, 19, wait a sec, what's that? Alright, 100 times. I like the 19 out of 20, but, so if it was conducted 100 times, then 95 out of those 100, or what they would often say, if it's conducted 20 times, then 19 out of those 20. Okay, so we're saying 19 times out of 20, or 95% of the time, the results would show between 80 and 84%. Well, 19 out of 20 is 95%, right? So I can say 19 times out of 20 times. In other words, 1 out of every 20 times you gave the survey, or 5 out of every 100 times, if you repeated that survey 100 times, 95 of them would show results between 80 and 84%. Okay, if you did the survey 20 times, then 19 out of the 20 times. Let's just pull that out. The general statement would be, the survey administrators are 95% confident. Okay, so when you read those survey results and they're saying 19 times out of 20, you could say, hey, we learned that in math. That's a 95% confidence interval, which means that we are 95% confident that between 80% and 84% of the students at town school would like a timetable change. Confidence interval. A statement that shows the range of the actual or true value of what is being measured. The confidence interval for the question regarding the timetable change is 82% plus or minus 2%. Okay, so you take that margin of error, you take the result is 82% of the students we surveyed wanted a timetable change. You take the margin of error, and your confidence interval becomes the result of the survey plus or minus the margin of error. Now, we only surveyed 300 students. Well, only. That 300 is actually a fairly large number for a school of 2,000 students. What we want to do is say, all right, if there are 2,000 students in the school, then determine the range of students. So we'd say, well, we know that at the low end, we've got 80%. So 80% of the 2,000 students, which is 1,600 students. And at the high end, we have 84% of the 2,000. Right? So on your calculator, you're just going to go 0.84 times 2,000 or 0.80 times 2,000. And 84% is 1,650 students. So we would say if there are 2,000 students, then 1,600 to 1,650 of them want a timetable change. Okay. No. It depends on these numbers, right? So if this was 90 and this was 3, then we'd go from 87 to 93, right? Okay, so we're saying from 80 to 84 based on this. 82 minus 2, 82 plus 2.
So for like 2,000 students, let's say it came to something like 16.4, you always round down, right?
Yeah, so with confidence intervals, really what we're doing is we're saying we have a normal distribution and what we want is 95%, right? So we're saying with a confidence interval, we're saying, you know, the results are going to come like this for any survey, right? Like there's very few people that are like, yeah, really good. There's very few people that are really down here. Most people are kind of in the middle. So when we say 95% confidence interval, we're saying that we've got 95% of the people, right, starting in the middle and working out 47.5% each way, right? So this area here is 0.95. That's what a 95% confidence interval gives you, right? It tells you we know the results are distributed, right? Every time we do a survey, 95% of the time it's going to fall in here, right? And this would be the 80 to 84, right? 82 in the middle, 80 down here, 84 up here, 95% of the data. But occasionally we'll do the survey, we'll get less than 80, right? About 2.5% of the time. And 2.5% of the time, because that's what's in here, right? 2.5%. And 2.5% is in the tails. So 2.5% of the time, we're going to get a number below 80, and 2.5% of the time. So for us, this is 82, this is 80, this is 84, right? And we're saying 95% of the time, we know the results are going to fall in there. Okay? And 5% of the time, they'll be outside of that. Now, as the sample size representing the population increases, so if we survey 1,000 students out of 2,000, what do we expect the margin of error to do? Decrease, right? It's going to get smaller because you're getting more people. Wow. Where did that go? Wow. Hang on, I got to read. So if the margin of error gets smaller, then the range in the confidence interval will also decrease, right? It's also going to get small. Means we can be more confident in that result, right? We're going to get tighter to the mean. Examples. Say it a bit louder, because then I won't have to read it. So we got massive sugar packets, ranges from 3.4 to 4.2 grams. Determine the margin of error and express it as a percent. Okay, so what we have to do basically is figure out, all right, we're varying, right? We're going 3.4 to 4.2 is either side of the middle. So we got to find the middle of this, right? So we need the mean. So man, this isn't going to last. Write it down quick, because this is just going to disappear in a second. Because it's a thin line. Thin lines disappear. See? Now it'll stay.
Can you write it again?
Yeah, but this time it'll stay. It's a thick line. Okay, so what's that equal to? What do we got? 7.6.
Why are we dividing by 2?
Because you'll see in a sec. We need the middle.
5.5.
So that's 3.8 grams, right? You're getting the middle can't be 5.5, right? You got to understand that much, right? So what you did was this: you went 3.4 plus 4.2 divided by 2, and what it did was said 3.4 plus, and it took 4.2 divided by 2, which is 2.1, and added that to 3.4, and there's your 5.5. Now I hope you would recognize that the middle of 3.2 and 3.4 and 4.2 is not bigger than either one or smaller. So on your calculator, put that in brackets. Or go 3.4 plus 4.2, enter, and then divide that by 2. Okay? Get the right number. So we know that we have this range from 3.4 to 4.2. So what's the margin of error? How far do we go to get from 3.8 to 3.4 or from 3.8 to 4.2? 0.4, right? So margin of error is 4.2 minus 3.8 or 3.8 minus 3.4. Okay, if you would like to talk, please take your conversation into the hall, and I will come get you when the lesson is over. Okay? Deal? Not mad. I will. I'm not right now. Okay, so the margin of error is 0.4. Now we need to express that as a percentage, right? So we're saying, what is 0.4 out of 3.8, right? It's got to be that middle number. It's this number, right? Because we're saying it's 0.4 of that 3.8. And to turn it into a percent, we multiply by 100. And what does that give us? A number. Congratulations. Like brilliant. See what I have to deal with? YouTube, you see what I have to do? What is it now? 10.5, thank you. So 10.5, and that is a percent, right? So it's 10.5%. And the margin of error is really 0.4 grams, right? Because we actually have a measurement on there. Right? We have units, so 0.4. Okay, so that's it for that question, right? We're not doing a confidence interval, we're just saying, hey, what's the margin of error? So you say, well, okay, we got to find the middle, right? Then we got to say, how much does it differ from the mean? That's the margin of error. If I want that as a percentage, then I take the margin of error divided by the mean and multiply by 100. Okay, so it's MOE, margin of error, divided by mu, which is the mean, times 100. That will give you the percent error. Okay. So you can change margin of error into percent error. Okay, that's how you do it. The hockey pucks used in the NHL must be between 160 and 170 grams. One manufacturer produces hockey pucks for the NHL and has more stringent specifications, which are tested by measuring the masses of random sample groups of pucks, right? So any manufacturing stuff is going to do that. They're going to have to test the stuff, right? I mean, if you're manufacturing bearings for, skateboard wheels or longboard wheels or whatever, there's different grades of bearings, right? And what that means is as you move up into the better grades of bearings, they're going to be have a closer tolerance, right? They're all going to be about the same size, more so than at the lower end. Or, if we have skates for like little kids, we don't really care about the bearings too much because we know they're just sort of, you know, going down the driveway or something. But if somebody's going to longboard down a hill wearing a leather suit on these wheels, they want them to be good, right? Anyway, if the mean mass of the sample is between 163 and 167 grams, then the equipment is functioning properly. So the confidence interval is we want to go between 163 grams and 167 grams, right? So that gives us, because we say as long as the pucks are between 160 and 170, they're okay. They're trying to say we want to manufacture them so they're between 163 and 167. Then if the odd one is out, it's probably still within the specs. Okay? Determine the margin of error for the mean mass of hockey pucks and express it to the nearest hundredth of a percent. Okay, so margin of error. So we need to find the mean of 163 and 167, right? Do we even need to calculate that? We know 165, right? If we do need to calculate that, then we just go 163 plus 167 divided by 2. So the mean, okay, is 165. The margin of error is, so how much are we going down or up? From 165, what's the margin of error? Okay, so that's plus 2, that's minus 2, right? So the margin of error is 2 grams. Margin of error. Okay, and you can calculate that as 167 minus 165 or 165 minus 163. And either way, we get 2 grams. And the percent error, we take the 2 and divide it by which number, which is sitting here before you? 165. So we take the 2 grams out of the 165 times 100 to turn it into a percent, and it's 1.2%. So we say plus or minus 1.2%. Okay, so margin of error, plus or minus, right? We probably fix that back here. The margin of error will be plus or minus, right? Because it's 0.4 either way, right? It's 0.4 up or 0.4 down. And on here, it's 2 grams below 165 or 2 grams above 165, plus or minus 1.2%. The confidence, oh, it's nearest 100. Okay, so what is it, 1.21? Thank you. Good to point out, right? Those little things, especially in Math 30-2, where the difference between right and wrong, and every question on that diploma is worth 1.25% of your final mark of the course. Right, so you're sitting there, you got 3 hours, and you're writing 40 questions, and each one is 1.25% of your final mark. So you don't want to round incorrectly, right? No point in, yeah, I know how to do the math and all that, and I just lost 1.25% because I didn't round it right. Confidence level the manufacturer has for the mass of the pucks depends on the sample size, right? So the larger the sample size, then the more confident we are, right? If you just take a small sample size, it's going to be spread out. Quality control engineering uses the following chart created by the company to determine the sample size. So if we want to be 99% confident, we need a sample size of 120. 95% confident, we need a sample size of 70. 90% confident, a sample size of 50, right? So they have to decide, because there's a cost involved in this, right? They got to pull pucks off the line. Somebody's got to sit there and measure them. That takes time, right? You're paying somebody. If you're manufacturing thousands of these things, you say, okay, we can take the time to measure 120 of them, right? Use the chart to complete the following statements. Based on the sample size of blank pucks, the manufacturer is confident that blank times out of 100, the mean mass of a hockey puck will be between. So basically, we're going to work our way through this chart, right, and filling it in. So, based on the sample size of, what do you want to start with, the 50 or the 120? 120? Okay. Based on the sample size of 120 pucks, the manufacturer is confident that 99 times out of 100 the mean mass of a hockey puck will be between what and what? 163 to 167, right? Back up here. 163 and 167. Based on a sample size of
95 or
70 pucks, the manufacturer is confident that 95 times the mass of the puck will be between, still 163 and 167. And based on a sample size of 50 pucks, the manufacturer is confident that 90 the mass will be between 163 and 167. So, the smaller the size of the sample, the blank confident the manufacturer can be that the mean mass of hockey pucks are made. So, more or less? Less, right? It'd be less confident. So if you do a small sample size, you're going to be less confident, right? You'll become a 90 times out of 100, they'll fall in that range. For the manufacturer to be 98% confident that the mean mass of the hockey pucks is between 163 and 167 grams, the quality control engineer would have to measure somewhere between, if we want to be 98 using this chart, we want to be 98, then how many pucks do we have to measure? Between 70 and 120, right? Okay. Now, there's math you could do with that. We're not going into the full detail on this stuff. You can do normal CDFs with it, and we used to do that in Applied 30, but we're just doing a kind of lighter version of it. Now, you might see this stuff, right? If any of you guys go on into if you go into nursing or something like that, or biology or that, you're going to see a lot of statistics, right? So in nursing, you see a lot of patient statistics. They're going to follow that normal distribution. You're going to say, hey, we saw that in high school, right? And they're going to say, we're 95% confident. It's, that's all confidence interval, right? And it means they lie within a certain range. And that's that margin of error. So it's the whole margin of error and percent error and that, and you're going to see that. And you'll just, your takeaway from this is, I'm familiar with this kind of stuff, I've seen it. Obviously you're going to learn it in more detail if you go on into something where they use that, but you've had an introduction to it. Okay, 3. Cosmetics company advertises that 85% of users saw reduced visible lines with regular use of their anti-aging cream. The company states that the results of the poll are accurate within 2.5 percentage points 9 times out of 10. State the confidence level and the margin of error. Okay, 9 times out of 10, what's the confidence level? As a percent. Yeah, so 9 out of 10 times 100 is 90%. Okay, so we are 90% confident. And what is the margin of error? MOE is 2.5, so plus or minus 2.5%. Okay, so remember, margin of error, you're going either way, right? 2.5 below to 2.5 above. State the confidence interval. Okay, so the confidence interval is, where are we doing the 2.5 from? What number? 85, right? Yeah. So they said 85% of the users, so it's going to be 85% plus or minus 2.5%. Okay? Well, we can just leave it like that. If we need to state the range, then we would say it's 82.5% to 87.5%. If 400 people use the cream, then determine the range. Well, this time we want the range, but we want it as a number of out of 400 people, right? So out of 400 people, we're going to say, all right, what's the low end of this? be 82.5%, and the high end of this will be 87.5%. So I want 82.5% of 400. Which is how many people? Number?
330.
330. Thank you. And I want 87.5% of 400, which is 350. So the range of people is from 330 to 350 people, right? So what we could say is the manufacturer is 90% confident that between 330 and 350 out of, okay, you got to say what it's out of. You can't just say between, out of 400 people will see reduced visible lines. Okay, and if they're going to make that claim in advertising, they have to have some study to back that up, right? They can't just say stuff.
Yep.
So if you're going to make claims with numbers, you're going to have to back that up by saying, yeah, we tested the cream and blah, 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 blah. Here's our sample size and so on and so forth. Okay, so points on confidence intervals. Margin of error. So if you're given a range, you find the mean. You find the difference between the mean and the upper number or the lower number. That's your margin of error. You state it as the mean plus or minus the margin of error. If it's numbers, you can turn the number into a percent by taking the margin of error divided by the mean multiplying by 100. Now you have margin of error as a percent. Okay? And if you use that, you can then change that, or do the calculations with a number of people, right? Figure out what percent of the people or whatever you're surveying.